What? No, it's all right. It's not like I don't do it like that. I just. Can you guys work on? I try to do like give them time to work on a problem and then I'll do it on the visualizer.
Yes.
That's what I do. Yeah. Hello guys. How are you? Excuse me, ma'am. Excuse me. Sorry. Can you guys start working on 6, please? I will give you 2 minutes in practice for you to do it by yourself, and then I will do it myself and visualize it after a few minutes. So this is. So question 6 is based on stuff we did last week. So you should be able to do it. If you look at the handwritten notes from last week, you should be able to do question number 6. Yeah.
That's because I missed Tuesday and Wednesday. Yeah.
Oh, you okay?
I'm going to have to do that.
Okay, good. There is an attendance sheet coming around. Make sure you sign your name before the end of the class. Before. No.
I've kneeled on it. You've probably done more than you and I. I think it's bad. We haven't gone to that yet.
Anybody here who hasn't got these handouts I gave on the first day of classes? Everybody has this or no? You have it, sir. I'm just making sure because you haven't.
I've got them.
Sorry, I didn't know. Sorry, ma'am. Alright guys, so I've given you enough time to do question 6, so let's see how we can do it. Right, so you have you have this. The question is to find the mean and the variance of x bar. Now, if you look at the handwritten notes I gave you guys, you should know the formulas for this and this. Now, what's the formula for this? You've been reading the notes or what? What's the formula for the expectation of x bar? is mu, right? And the formula for this is sigma squared divided by n, which is 10 here. Do you see this or not? I mean, if you look at the handwritten notes, guys, can you see these two or not? Right? Where mu is the expectation of x, so the expectation of a uniform variable between 0 and 1, which is, hello guys, do you know the expectation of uniform 0, 1? What's that? It's half. And sigma squared is the variance of a uniform 0, 1, which is 1 over, I'm just checking your memory, guys. If you look at, you know, on the first day of classes, I gave you this handout here. Do you remember this or not? Or do you have a copy of this or not? This is a list of probability distributions. And if you look at page 3 of it, which is this one, this is the mean of a uniform variable, and this is the variance of a uniform variable. So the mean is a plus b by 2, and the variance is b minus a squared by 12. So that's what I have used to get this and this, right? So hence, the expectation of x bar is a half, and the variance of x bar is, right? So that's all you're asked to do. Is this difficult, guys, or not? It's not. I mean, any questions on this, guys? You ma'am, okay? No. All right, can you do question 7, please? 7. And you guys do 7, please, to the next question. Tim, do you have the sheet? Do you have the sheet? No, the question. Is this okay with these guys? Yeah. You follow this? All right, can you do the next question, please? 7, please. Just delete the last one, guys. So you only have, there's a matchup. I think the last one shouldn't be there. So x1 is 9, then 13, 6, 8, and 10, right? I did this also in the notes, the handwritten notes. You can access online.
What's the joint of the so I would call like 9 equals 69 with that and then sort of like that.
You guys okay? Are you guys good? I said, good. Alright guys, I've given you time to do question 7, sorry 6, 7. So let's see how we can do it. So here we have 5 random variables, it's a random sample. Now the question is asking you for the joint probability. Okay, it's asking for the joint probability, which is the same as the joint PMF, which I talked about in the class. You may recall this on, I think it was this Tuesday or last week, I can't remember. Which is the probability that capital X1 right? Because you have a random sample, X1 to X5 are independent random variables, right? So you can write this as the product. You know, this sign here means product, guys, if you don't know that already. It means product I from 1 to 5 of the probability that capital Xi equal to little xi. That's using independence, right? And because xi has the Poisson distribution, you can write it like this, right? And now you're going to take the product of this. This is where your math comes in. I mean, as I said before, many people get this wrong. Okay, like this. Do you follow me? Now, when you take a product, this becomes, when you take the product of EM minus lambda, it becomes 5 lambda. Yeah? When you take the product of this guy, it becomes this. When you take the product of this guy, it becomes this. Right? Now we are given the values for x1 to x5. So now if you sum these values, 9 plus 13 plus 6 plus 8 plus 10, what do you get? I mean, my math is it 46? Is that right? Divided by 9 factorial, 13 factorial, 6 factorial, 8 factorial, and 10 factorial. Right, so this is the joint probability. Okay. Now the question is the second part is to find out to compute this joint probability at the values lambda equal to 10 and lambda equal to 12, and choose the one that gives the higher. Okay, choose Alright, I'm not going to do that because I don't have a calculator with me, but I'm sure you can do it. Right, you just compute these two values, right? You get two different values and choose the one that gives the higher probability. Right? Alright, any questions on this, guys? This is difficult or not? Come on, guys. This is difficult or not? Alright. Can you do question 3? Can you do 3, please? Question 3. sign the attendance sheet, guys. Anybody who has to sign? Where is it? You're not. Okay, sign it.
Where's all the
Are the numbers like all Did you see the chat? I missed it. Basically, I asked a question. He was like, if you yeah. Then well, then it's pretty foolish to complain about university not teaching. But that's what I said. You expect to arrange for your information, and he's lost it. Alright.
For the exam, you only need to know the stuff
Try
in
being
the
confident
end.
about that. Yeah, be kind of like, if you have to do it, like, and you put something else, but then later on end up right, we watch the thing, I asked questions, so is that about that? I don't know, maybe. So I was like, and then I asked are you in the chat? I'm the one who always asks questions. I've always got my phone, you know. Oh, I love people who do that. That's true. Kind of see, I just came through it, I don't know, I'm reading. Imagine if you had a race today. I did so pissed off.
Guys, shh, can you listen please? The first part is to find the population mean. Now in the lectures, what is the population, what did I tell you about the population mean? What is that equal to? The population mean is what? It's the expected value, right? It's the expected value. The expectation is the same as the population mean of whatever, right? In this case, the expectation of x is the population mean. And this, because x is a discrete variable, you're gonna, I mean, you know from probability 1, this is the formula. Because you have five data points, you need to sum from 1 to 5. So this will be 2 multiplied by, I'm going to use this sign, 1 over 5 plus 3 multiplied by 1 over 5, and so on up to 11 multiplied by 1 over 5. So if you work this out, you will get the answer 6. Is that right? You all got this right? So this is the population mean. That's part 1. Part 2 is asking you for the population thank you. It's asking you for the population variance. And if you look at my note, my handwritten note, you will see the population variance is denoted by this. It's also known as the variance of the variable of interest, which is the expectation of x squared minus the square of the expectation. We already know this guy, which is 6, so it's going to be Okay, so this is the expectation of x squared minus 36 because the expectation of x is 6, right? So if you work this out, you will get the answer 10.8 if I'm correct. Okay, are you okay, guys, so far? So that's part 1 and part 2. The next part is to it's a little bit more tricky because part 3, okay, here we are drawing a sample of size 2, right, from the numbers 2, 3, 6, 8 and 11. So the possible outcomes, well, you need to have basically 3 columns. This is column 1 giving the outcomes, column 2 giving the x bar, the sample mean of the 2 outcomes, and column 3 giving the probability. Outcomes, now how many outcomes will there be? You have 5 numbers and you're drawing 2 numbers with replacement. So how many possible outcomes can you have? 25, exactly. So you can have the outcomes 2, 2. That's the first one. Yeah? Or you can have the outcome 2, 3. You can have the outcome 2, 6, 2, 8, 2, 11, and so on. I'm not going to write all the 25 outcomes here. It will take me forever. So these, you're going to have 25 outcomes. For each outcome, okay, for this x bar is 2, for this x bar is 2.5, for this x bar is 4, for this x bar is 5, and for this x bar is 6.5, right, and so on. So you need to complete this table, right? And the probabilities, because all the 25 outcomes are equally likely, right, the probability of each outcome will be 1 over 25. Okay, so once you complete the table, then the remaining questions are straightforward. All right, so for example, if you want to work out the expectation of x bar, all you have to do is just multiply this column with this column and take the sum. So it will be 2 multiplied by 1 over 25 plus 2.5 multiplied by 1 over 25 and so on. Okay, and if you do the math, you will see this will become 6. Okay, and to find the variance of x bar, you do the same as before. So you find the expectation of x bar squared minus this, right? Which is this guy we already know, so you just need to work out this guy here. It's going to be 2 squared 1 over 25, 2.5 squared times 1 over 25, and so on, minus 36. And if you do the math, you will get the following. Let me see, is 5.4. Okay. Okay. So it's not difficult, is it, guys? So the most difficult part is to draw the table, right? So the only difficult part is to draw this table. So you should have 3 columns. The first list all possible outcomes. The second list the values for x bar for each outcome. The third are the probabilities, right? Okay, any questions, guys? Can you do question 4, please? Question 4, next. Has anybody not signed this form yet? Anyone here? Okay, thank you.
That's how you avoid hangovers.
You can, yeah, it's a simple way.
Drink some.
And both have yes. Yeah, both have
Literally bought like a trifle and thought, oh, I got back. And I was like, I don't even want to try. I just saw it and I was like, yeah, that's nice.
Also, it's about we're doing another table.
Alright guys, question 4 is the same as question 4 is the same as question 3. Can you listen please? Question 4 is the same as question 3. The only difference is that the sampling is without replacement, right? So you want to do the same thing. We have 3 columns: outcomes, X bar, and the probabilities. So how many outcomes will there be, you think? 20, yes. So the possible outcomes, let me write them down, is 2, 3, 2, 6, 2, 8, 2, 11, 3, 2, 3, 6, 3, 8, 3, 11, then 6, 2, 6, 3, 6, 8, 6, 11, then 8, 2, 8, 3, 8, 6, 8, 11, and finally 11, 2, 11, 3, 11, 6, 11, 8. All right, so there are 20 possible outcomes, and for each outcomes, I'm sure you know how to compute the average. So for this one, for example, this will be 1.5. For this one, this will be 4. This one, it will be 5, and so on. Okay, and the probabilities will be all equally likely. So it will be 1 divided by 20, 1 divided by 20, 1 divided by 20, and so on. All right, so once you completed this table, which I have not, but once you completed this table, the rest is trivial, right? All you just compute the expectation of x bar and the variance of x bar in the same way I did for question 3. Okay, guys? Any questions, please? The solution, the full solutions to all the example sheets are online on the course website. I'm sure you know where the course website is. If you don't know, all of you guys know where the course website is. So if you go online, you will see the full solutions to all the examples. Oh yeah, yeah, stupid me. Yeah. I don't know math, man. Should be 2.5, yeah. Yes. Question 4. Hello guys, if you've done quiz 2, you can hand it to me now. I've already done quiz number 2. Otherwise, have a great weekend, guys. We will see Have a good weekend, sir.
Just guess. Oh yeah, I am.
Did you have a copy of the sheet that you gave out last week?
Yeah, you mean the whole thing? Yeah, I have this one, you mean.
Is it?
This is the whole thing I gave out last Tuesday.
Oh, okay.
Thank you, man. Have a good weekend. Yeah, this is everything I handed out last Tuesday. Thank you. Have a good weekend.
I didn't pick up the notes last Tuesday.
No, you were not here? No.
Thank you. Is everything on the course?
Yes.
Thank you.
Have a good weekend, man.
Sir, I don't know when my name do not appear on the register paper. It's okay on me.
Yeah, it's okay.
It's okay.
Yeah. Did you sign the sheet?
Yeah.
Okay, that's okay then. It's okay. If you sign the sheet, that's fine.
It's not. Maybe just the system's error.
Yeah. But you get my emails, right? Do you get my emails from me?
Yeah. And then you edit my name on the register.
Okay. All right. Don't worry. You guys have a good week.
You too,
Any
sir.
problem, just email me or Zoom. Okay. Yeah. Hello, sir. You done?